So this question, we're given the function h of x, which is 5 times x minus 2 squared plus x minus 2 minus 4. And we're told h of x is also f circle g of x. We want to identify what is f of x and what is g of x. So let's make sure we're clear on the notation for composition of functions. Again, I have f circle g of x, which means f of g of x. G of x is the inside function. When you look at the f of something is what h is going to be. So f of g of x is f circle g of x is h of x, which is this 5 times x minus 2 squared plus x minus 2 minus 4. So again, what does that tell us? Then f of g of x is 5 times x minus 2 squared plus x minus 2 minus 4. So then what is my inside function? What is my g of x? What is my inside function? G of x will be what is being operated on, and that of course is x minus 2. So we'll say here is we'll say g of x is x minus 2. And then let's remove the x minus 2 and the g of x from the previous statement. So what I have then is I have f of what used to be g of x, and I'm just going to put in parentheses. F of g of x is 5, what used to be x minus 2, I'm going to put in parentheses, squared plus parentheses minus 4. So I determine my inside function, and then I replace it with parentheses. So f of x minus 2, right, or f of g of x, 5 times x minus 2 squared plus x minus 2. So f of something is 5 times something squared plus something minus 4, and that something, of course, is x. So we get f of x is 5 times x squared plus x minus 4. So we have our f and we have our g. If you do this, it's certainly a good idea to run it the other way to see if that really is the case. So what do we want? We want h of x to equal f circle g. So now that I have f and g defined, let's take a look at f circle g and see if that turns out to be correct. So what is f circle g of x? That, of course, is f of g of x, which is, of course, f of x minus 2. What does f do? 5 times something squared plus something minus 4. But it's f of x minus 2, so replace the somethings with x minus 2. And you'll see that indeed that's the h of x that we wanted. So this is our h of x, and that checks. So what's our process? Identify your inside function, remove it, and then replace your something with x, and that should work for us. So we've got one more problem like that. So here we have h of x is square root of x squared plus 9. I want h of x to be f circle g of x. So f circle g of x again, that's our h of x, is f of g of x. So it's f of something, and that's supposed to equal h of x. And what is h of x? H of x is the square root of x squared plus 9. G of x is the inside function. So if I look at h of x, what is on the inside? And I hope you can see that it's going to be the x squared plus 9 part. So again, h of x is f circle g of x, that's what we want, which is going to be the square root of x squared plus 9. we're saying the inside function, g of x is the inside function. So g of x is going to be x squared plus 9. Okay. So then h of x, which is f circle g of x, which actually means f of g of x, right? So if I replace the x squared plus 9 just with parentheses, what do I have there? What do I have there? Well, then I have h of x, f of g of x is what? Is h of x, which is the square root of removing the g of x, because that's just going to be something. So what does that tell me? That tells me what f of x is. F of x is going to be the square root of something. F of x is simply going to be the square root of x. That is our outside function. So our inside function is x squared plus 9. Our outside function is square root of x. So if we want to check that, how am I going to check that? F circle g of x is f of g of x, which is f of, we said g of x was x squared plus 9. F do square root of something. F of x is square root of x, so f of something is square root of something. What's the something? The something is x squared plus 9, and that checks. And that's how we decompose functions.